All right, let's do the combinations of functions worksheet. Our first one here is a combination of functions in itself. We need to distribute that -2. So we've got a 3 minus 5x squared minus 7x minus 2x cubed plus 6x squared minus 8. And if we simplify that and write it in descending order, we're going to start with a -2x cubed. We've got a plus 1x squared, a minus 7x, and 3 minus 8 is -5, so that simplifies to that. Okay, for this function, where is the horizontal asymptote? Well, we could get that a number of different ways. I'm going to go ahead and do it via arrow diagram. So we would subtract 5, that goes into the power of 10. We multiply by 3, change the sign, and add 2. And on the parent function here, normally we would say that as we go to -infinity, this goes to 0. That's where the horizontal asymptote is on there. And so our horizontal asymptote has an equation of y equals something. So that's an output. We'll see where this arrow goes. 3 times 0 is 0. The opposite of 0 is 0. 0 plus 2 is 2. So the horizontal asymptote is at y equals 2. We don't need to know the other stuff that's going on with the graph if the only question is about where the horizontal asymptote is. Okay, so we're going to use these functions to do some combinations. We want h minus j of x. Well, h is 2 over t minus 3. Minus j would be minus 2 to the m plus 1. Its domain, if we looked at these, we've got a division by 0 issue on this part. There's nothing in the exponential. A domain of an exponential is all real numbers. But this one, the domain would be that t cannot equal 3, or if we were using interval notation, we'd say it's from -infinity to 3, union 3 to infinity. Okay. And find h minus j of -1 if we put a of x. So on that original function, these variables are now going to be x's. And now if we replace those x's with -1s, I'm going to get 2 over -1 minus 3 minus 2 to the -1 plus 1. And -1 minus 3 is -4. 2 over -4 is -1/2. 2 to the 0 power is 1, so -1/2 minus 1 sounds like -3/2. Okay. All right, write r times j of x and state its domain. So using the x again, the r is 1/2 log base 3 of x times j, which is 2 to the x plus 1. Okay. That is r times j of x. It has domain restrictions because of the logarithm that says the x values have to be greater than 0. Again, nothing in the domain, no problems in the domain on the exponential, so we could write that way, or we could write it as 0 to infinity. All right, so let's see. We've got that as our domain, and now evaluate that at 3. If we replace all the x's with 3's, we're going to have a 1/2 log base 3 of 3 times 2 to the 3 plus 1. Well, the log base 3 of 3 is 1, so that's a 1/2 times 2 to the 4th power. Which 2 to the 4th power, 2, 4, 8, 16, and 1/2 of 16 is 8. So that is r times j of 3. And this is r times j with its domain stated in a couple of different ways. All right, h divided by r. So our h is 2 over t minus 3, or x minus 3, because we're evaluating at x, divided by, so that's over r, which is 1/2 log base 3 of x, which is the same thing as 2 over x minus 3 times, if we flip that over, it's going to be 2 over log base 3 of x. So this is like a 4 over x minus 3 times the log base 3 of x. The domain here, well, we know that x can't be 3, and x certainly has to be bigger than 0, or we can't evaluate the logarithm, and the log at 1 is also going to be 0. So it looks like in stating our domain here, we can start at 0 and go up to 1 but not including 1, pick up on the other side of 1, go to 3 but not including 3, and then go from 3 out to infinity. Okay, so kind of 3 parts in there. We have to avoid the 1 and the 3 because the log of 1 is always 0, and that would put a 0 in the denominator. And the log of, 3 minus 3 would make a 0 here. So those are the 2 numbers that we have to avoid. We're going to be okay everywhere else. And if we try to plug a 1 into that, then we're going to get a 4 over, 1 was not in our domain. Okay, so we don't even have to do this part. Once we recognize that the 1 is not in the domain, we say that this is undefined. Okay, there is no value of this function at 1. Okay. All right, and finally, evaluate 3 times h of 6. So that would be 3. Our h here is 2 over t minus 3. We're putting a 6 in there. So 3 times 2 over 6 minus 3 minus 8 times the 1/2 times the log base 3 of 27 divided by j of 2, that'd be 2 to the 2 plus 1. So let's see here. 6 minus 3 is 3. That's going to cancel with this 3 and make that part just a 2. Half of 8 is 4, so this is minus 4. 27 is 3 to the 3rd power. So log base 3 of 27 is just 3. So we've got a 4 times 3 there. That's 2 minus 12 over 2 to the 3rd power, which is 8. So I get negative 10 over 8, which reduces to negative 5 over 4. Okay. And then finally, sketching a graph of 1/2 of h plus j of x plus 2. Okay. Let's take a look at what h plus j of x looks like again. So, or I guess we haven't done that one yet. So h plus j of x would just be 2 over x minus 3 plus 2 to the x plus 1. Okay. And we're going to want half of that, and this part over here, there's been a transformation that has been made to that. So this is kind of a semi-complicated transformation. We're going to try to grab various points off of this, but this is going to be our h plus j arrow. And starting with the x, though, we started with the x and we added 2 and that went into the h plus j of, and then we multiplied by a half. So let's see if we can grab some important points here. We know we have some issues here. Let's go ahead and just grab several of them along the way here and see what we can get. So I'm going to go with -2, -1, 0, 1, 2, 3, and 4, and see if this gets us an idea of what this looks like. Okay. -2, if I plug it in here, I'm going to get 2 over -5, so that's -2/5 plus 1/2. So -2/5 plus 1/2, that is -4/10 plus 5/10, which is 1/10 that comes out here. Yeah, so that's going to be fairly close to 0. This way I would have to subtract 2, so I'm going to get -4, 1/20 is on this graph. So that's basically 0 back there. If we put a -1 into this function, we're going to get a 2 over -4, so I'm going to kind of erase some things because I've got a lot of space that I need in here. 2 over -4 is a -1/2 plus 1. That's going to give me a 1/2 out. Half of a half is a fourth, and -1 minus 2 is -3. So at -3, 1/4 is about right there. Okay. If we put a 0 in, I get a -2/3 plus 2. Sounds like a 1 1/3, or 4/3. Half of 4/3 is 2/3. And 0 minus 2 is -2. So at -2, I'm at about 2/3. Looking kind of exponential in there, like the exponential part is taking over here, although the reciprocal function looks that way as well. All right, if we put a 1 in, I'm going to get 2 over -2, which is a -1, and plus 2 squared, so plus 4, so that's 3. Half of 3 is 1.5. So -1, 1.5 is on this thing. If I put a 2 in, I get 2 over -1, which is a -2 plus 2 cubed, which is 8. 8 minus 2 gives me a 6. Half of a 6 is a 3. So this has an intercept at 0,3. Kind of getting the idea of what it's looking like here. If I try to plug a 3 in, though, this is undefined, and this will give me a vertical asymptote, because that's what happened on that reciprocal function there. And the vertical asymptote, half of a vertical asymptote is still a vertical asymptote. 3 minus 2 is at 1. It says I have a vertical asymptote here. So I'll kind of sketch that in, and then we'll get an idea of what things look like on the other side of this. If we put a 4 in, create some more space for myself again. I'm sorry, I had that off the graph a little bit. So if I put a 4 in, I get 2 over 1, which is a 2, plus 2 to the 5th power, which is 32, So 4 gives me a 34 out of that as a 17, and so I'm at 2, 17's way up there somewhere. And I think as I keep putting bigger and bigger numbers in, this part is just going to keep growing it bigger and bigger, so I can't really see what's happening so much on that side. So I imagine that it's coming down here a little bit and then growing off this way pretty much exponentially. Over here, pretty confident that it looks something like that. Okay, so not a perfect graph, but demonstrates how it is that I can use just points plugged in there to get an idea of what the shape is. I wanted to make sure that I put the 3 in there because I knew it was going to cause a domain problem. All right.